trend peak, a negative trend in pressure and air density and the velocity, consistent with the velocity profile that is in the duct. Also, at a fixed depth, we expect to see an increase in the air velocity and a decrease in the air density as air temperature and fan speed increases. And thirdly, for a constant depth, we expect to see a conservation of energy consistent with Bernoulli's principle using our calculated values.
So our project goals are to reduce the effects of previously mentioned contributors of error, optimize the functionality of the wind tunnel by establishing operating conditions, obtain meaningful quantitative data from testing, and interpret that data to reach a conclusion. So for a little bit about our background, a pitot tube, which was our main instrument for this lab, or this experiment, is a dual pressure tap instrument that measures the difference between stagnation or total pressure, which is normal to fluid flow, and static pressure, which is parallel to fluid flow. Most commonly, it is used for aerodynamics to measure fluid pressure, which can then be used in Bernoulli's principle to find the velocity of a fluid flow. Fluid density can be calculated using secondary equations or calibrated gauges. In this diagram, you can see its static pressure taps are at 1 and 4, and stagnation pressure taps are at 2 and 3. The most common application is aerodynamics, and that's seen here in this next slide on planes. So the air comes in through the pitot tube, and rather than using calculations, it uses gauges to determine velocity and altitude.
So next, the pertinent principle that was used for this experiment is obviously Bernoulli's principle. So this concept represents a conservation of pressure along a streamline, conservation of energy. So we have static, dynamic, and hydrostatic pressures that were constant. And it states that in a flowing fluid, an increase in fluid's velocity is accompanied by a decrease in pressure, showing that inverse relationship, and then vice versa. So, yeah.
Up next, we had the path. So we started with our hypotheses, and we want to reach a conclusions, but we had to figure out how we would get there, and that was our method.
So here we have the methodology, which is known as the path. So first, we had to start off with our design phase. So after completing the lab flow, we decided to come up with a way to reduce the errors. So we were thinking about designs like, how can we keep this pitot tube in place so that we wouldn't have to, so that we wouldn't see the human errors from holding it. So then we proposed the solution. It took a couple of tries. We had a couple different designs, but we finally came up with something. Then we used Fusion 360 to design it. We 3D printed the designs in the LC's makerspace, and we tested and fitted and revised as necessary. Then next, for the testing phase, we used the 3D printed solution again for testing. So we came in here, we started up the wind tunnel, and we saw how the design held up as we tested for like a certain condition, and then we collected numerical data on that. And then lastly was the analysis phase, where we analyzed our numerical data collected. We created visual representations of the data, so that's the graphs showing the different relationships, and then we interpreted the data and created our report lastly.
So for our design phase, we went into it knowing that we had to meet certain requirements regardless of the design we proposed. So first of all, we had to create an airtight seal. That way we wouldn't leave the opportunity for a static pressure tap at the cutout where our design would be inserted. We had to incorporate the pitot tube to the design seamlessly because that is the basis of this whole design. We had to be able to work with height, as one of our requirements was to collect data for the middle 60% of the test area. We had to withstand high fan speeds, being that we were going to run between 20 and 60 hertz. We had to have a modular design because we were working around an existing 1-inch hole, and we had to make sure it was repeatable, being that it might be used in the future.